Okay, let's look at question number 11, part B of the applied paper. So, this is the relative velocity question. So, river with two straight parallel banks flows with constant velocity u. The points A, B, and C are on the river bank such that ABC angle is 90. It is also given that AC is A. So, this length is A. And BAC angle is theta. Right, those are marked in the figure. A swimmer can swim with a constant speed of 2u in still water, starts at A and swim along a straight line to B, reach B. Then he swims along straight line to reach C. Assume that no time taken for turning. By constructing velocity triangle for the motion from A to B or otherwise, show that the magnitude of the velocity of the swimmer along AB is that, right? Okay, so let's note down the velocity is given to us. This one is the first one. River flows with a constant velocity u in this direction, so that is water relative to earth, which is in this direction. Then that is done. Then swimmer can swim with a constant speed 2u in still water. So v swimmer relative to water is 2u. Do we know the direction? No, we don't know the direction. So let me put a circle there. And then we want to find the magnitude of the velocity of the swimmer along AB. So we know swimmer's velocity relative to earth should be what? The direction we know. The direction should be theta angle to the horizontal, right? So those are the things we know. So that is for, this is for AB section. Then for the BC section, velocity of the swimmer relative to earth should be in which direction? What is this angle? This is 90 minus theta, no? So then this has to be 90 minus theta. So the horizontal 90 minus theta, right? So we mark down everything that is given to us. So now let's draw the velocity triangle. So we'll use what? VSE equals what? VSW plus VW earth. So W is the one we know both the direction and the magnitude. No? So we'll put VWV first, then VSW. So because A plus B or B plus A is the same in vectors, because vectors are commutative. So I will write it like this, the same, because vectors are commutative, right? So then this is theta angle, this is U plus 2U, we don't know direction, we know only magnitude. So let me take this as PQ plus QR. So this is PR. PR is the length we need to find in our velocity triangle. We want the magnitude of the swimmer along AB, right? So this is for AB. So then let's try to draw it. PQ will start with the vector we know, size and direction. So P to Q, U. Then QR, length is 2U. So we'll take Q as our center and draw what? A circle of radius 2U, right? Circle of radius 2u. Right. So this length is 2u. Okay, q. Right. Then we'll use PR. PR has to be theta angle to the horizontal. So this is, then that is the direction of QR. Right. This is 2u. Right. PR is the length we need to find. This angle is theta. So we need the magnitude, no, magnitude of velocity for the swimmer along AB. So we need to find PR length. So then let me use this triangle, PQR triangle. Let me draw this perpendicular line and let me label this as S. So now we'll use that triangle PQS triangle and find PS, right? PQS triangle is a right angle triangle. So then PS is what? PS is U cos theta and SQ is U sin theta, right? Then we have PS. Now we need SR length. To find SR length, you have to use the other right angle triangle SRQ. So now we'll use the other right angle triangle SRQ. I want to find SR length. Then I can find PR length, which is what we are looking for. SR squared is what? We'll use the Pythagoras theorem. SR squared is equal to what? QR squared minus QS squared. QR squared minus QS squared. QR squared minus QS squared, right? QR is 2u. So then SR squared is what? 4u squared minus Q. Wait, let it more clear. 2u whole thing squared minus QS. We found SQ is same as QS. U sin theta squared. So then SR is what? Square root of this, which is 4u squared minus u squared sine squared theta. So that is same as, you can take a u out, 4 minus sine squared theta. So then we want to find PR. PR is made up of what? This length is made up of PS plus SR. PS plus SR. PS is u cos theta. SR is u, this one. Right. So then we have it. Look at the answer and simplify. You want everything in terms of cos. So I just need to get rid of that sine squared part. So replace sine squared with 1 minus cos squared theta. Then you have the answer. Take the u out. So cos theta plus 4 minus 1 minus cos squared theta. Replace sine squared with that and simplify. So cos theta 1 minus 1 and 4. So then 3 plus cos squared theta. That is what we want, right? So that is the magnitude of the velocity along AB. So let me label it as simple V. Then this represents absolute value of V or magnitude of V. Right. So that part is done. Then what are you supposed to do? Deduce the magnitude of velocity along BC. So what's the thing that changes here for BC? This direction or this direction would be 90 minus theta now. PQ doesn't change, no, that is same. This one will change, but the magnitude doesn't change. So it will be PQ plus QR1 equals PR1. So similar triangle you will create with the angle 90 minus theta. So the only thing we need to change in this magnitude is the angle. You have to replace theta with 90 minus theta. Then you will get the magnitude of velocity along BC. So let me also draw this so with a different color. So this would be like this. This angle is 90 minus theta. And this is going to be R1. So we have to figure out this one. So let me label this as V dash. So we have to find, no, wait, not that one. That is 2U. That is 2U, sorry. We need to find this one, V dash. PR1. So same type of triangle as PQR. So only thing that changes is this angle 90 minus theta. So same method. So you can use this formula that we found. Replace theta with 90 minus theta. So let me label this as 1. Replace theta with 90 minus theta in 1. Then you get V1 velocity magnitude. So U is outside, cos 90 minus theta plus 3 minus, sorry, 3 minus, so plus 3 plus cos 90 minus theta square. So that will give you U sin theta plus square root 3 plus sine square theta. So that is the magnitude of the velocity along BC. Then what you supposed to do? Also show that the total time taken by the swimmer to reach C from A is this. So then we need to find the AB time plus BC time. So that is the total time. So total time equals time AB plus time BC. Time AB is what? Distance AB over speed plus time BC would be distance SBC over speed of VB, speed of BC, right? So speeds we found, distance we need to find. So we have to use this length is A, no? So then AB length is what? A cos theta. So this is AB is A cos theta, BC is A sin theta. So now we can write A cos theta. This one we found, this one plus SBC A sin theta over V dash modulus. Right. So then substitute those and let's simplify. So total time is a cos theta u cos theta plus square root 3 plus cos square theta plus a sin theta u sin theta plus square root 3 plus sin square theta. Right. So now this is the total time, but that is not the expression we want. So we want a over 3u out and some other part. So let's see. We can take a over u out. That part we can take out. Then cos theta plus root 3 plus cos square theta plus sin theta over sin theta plus root 3 plus sin square theta. Right, now let's see how to get this. So inside the bracket there's no denominator. On outside it should be a over u 3, a over 3u, not a over u. I have a over u, I need a 3, and the inside I don't want any denominators. So here I have to make this denominator into 3 in both of them. If you take common denominator of these two, it just becomes a complicated expression. But if you see, if I multiply by the conjugate of each of these, then I can create 3, because the cos squares and the sine squares will cancel out. So do it like this: multiply both the numerator and the denominator by the complex conjugate. Not the complex, sorry, not the complex conjugate, just the conjugate. Plus, same thing for sine theta. You multiply by sine theta minus root 3 plus sine square theta, and sine theta plus root 3 sine square theta into sine theta minus root 3 plus sine square theta. Right, now simplify. A over u, you get cos square theta minus cos theta, this one, and the denominator is what? Cos square theta minus 3 plus cos square theta. This is using the difference of squares. This is a plus b times a minus b type, plus this one will give you sine square theta minus sine theta into 3 plus sine square theta, right? Then sine square theta minus 3 plus sine square theta. Right, simplify. Cos square theta cancels, sine square theta cancels here. So you get a over u cos square theta minus cos theta, this over 3, right? No, over minus 3, plus sine square theta minus sine theta 3 plus sine squared theta over minus 3 again. So then take a minus out from the numerator. Take a minus out from the numerator here, so the minuses cancel out. You will get what? A over u cos theta, this minus cos squared theta, and we'll put all the things under one denominator. Denominator is the same for both, so this will give you plus sine theta 3 plus this minus sine squared theta over 3. Now take 3 out, so now the outside part is done, and then you can write this plus this, and minus cos squared theta minus sine squared theta is what? Take the minus sign out. Cos squared theta plus sine squared theta, which is 1, so minus 1. So you get minus 1 like that. So let's check if that's the answer. Yes, a over 3u cos theta, that root part, plus sine theta, that root part, minus 1. Right. So we get the answer. Right. So that is the relative velocity question. Next, we'll do the relative acceleration questions, wedge and pulley ones.